Okay, so looking at angles in a circle, we're trying to make an isosceles triangle in order to be able to solve this first example. It's telling us the angle OAB is 42 degrees and we want to find AOB. Now you can see we've got a circle here and we've got a chord marked on, so that's this line AB. A chord is any line that goes from one side of the circumference to the other. A diameter is a special type of chord because it's the one that's the longest chord and it goes from straight through the centre. So as I say, AB is what's known as a chord. Now we know that in a circle, any line that goes from the centre to the circumference is called a radius. So if we draw in a radius from the centre to point A and from the centre to point B, these are both the same length, and so we've now created ourselves an isosceles triangle. We also know that the properties of an isosceles triangle are that the base angles, so this angle OAB is equal to this angle OBA. Remembering that when we're writing angles, the letter at the angle vertex is in the centre of your angle. Now, it tells us at the top there that OAB equals 42 degrees. So that's this angle over here, that's 42. And we've just decided that OBA is the same size, so this angle here is 42 degrees. The other angle property we need to remember is that the angles in a triangle add up to 180 degrees. So if we want to find OAB, which is this angle, AOB, which is this angle at the top, then what we're going to do is we're going to start off with 180 degrees, and we're going to take away 42 plus 42. And that equals 180 take away 84. And so therefore angle AOB is going to equal 96 degrees. Now, if the question gives you the angle at the centre, then you're going to take that away from 180 and then you divide by 2 to get the base angles. Right, so that's pretty straightforward. To make it a little bit trickier, we're going to move it up and start thinking about using Pythagoras, or you could perhaps use SOHCAHTOA if you were given an angle. In this particular one, it's giving us some information and it's asking us to find x, which is kind of like the depth of the space between the chord and the circumference. So again, we're given some information, so let's mark it on. The chord length is 24 centimetres, so that means that from there to there is 24 centimetres. It tells us that the radius is 13. So if we draw in our radius to make our isosceles triangle. Now, we don't have enough information yet to be able to work out what x is. However, there's something called a perpendicular bisector, and a perpendicular bisector is basically a line that goes from the centre and it slices the bottom into two equal parts, creating, because it's a perpendicular bisector, a right angle. So if we draw a sketch of this triangle separately, then we can see how we can go about using Pythagoras. So we know that the long side is 13 centimetres. We know that this side from the middle to this point here is going to be half of the length of 24. So this is going to be 12 centimetres. And we want to find out what we call it h for the height. Now, Pythagoras says that if you have a long side there, you're going to do subtraction. So we know that h is going to be the square root of 13 squared minus 12 squared. And to put all the working out on there, but if you've got a calculator you don't need to, that's 169 take away 144, which is the square root of 25, which happens to be 5 centimetres. Now that's not the end of the story. We know that this bit from here to here is 5 centimeters, but we know that the entire length from the center to the circumference is 13 centimeters. So to work out x, we need to do the radius, take away the 5, and that gives us a value of 8 centimeters. Now, some questions will ask you to work out from the chord to the top, and you would just take your 5 centimeters and add it onto a radius in order to get the opposite measurement, because you know that the entire measurement from the top to the bottom is going to be 26 centimeters. Okay, hope that helps. Any questions, just ask me. Thanks, bye.